useful sometimes if you want to compare. Let's say this is what that we did the other day. We end up with this last example about this network. Sometimes if you want to compare the different set of data, so even if you know, some people, they will say, I'm going to compare their mean, their median, or the mode. But sometimes a set of data would be given to you that they have, everything is going to be the same. They have the same mean, the same median, so you cannot compare them together. So you need some other tools, okay, some other measures to be able to find out. These type of measures are going to be called measures of variation. I'll give you one example to get the idea of why we need this type of ideas, and then we go for it. This section is very important. Introduce two famous quantities that we are going to use it for the rest of the course. So pay attention to this one, and anywhere you feel that you need more explanation, just let me know, okay? So very important section, 3.3.2. It's very dense. You are going to get 2 or 3 questions from this one on your next test number 1 in 2 weeks' times. So what is going to be measure? Okay, what is going to be measures? Measures of variation this time. Okay, measures of variation. So let's see why we need it. So we'll start with this question, you see. Suppose you want to answer this question. Just want to know why we need it. The question is going to be, we are going to consider 2 basketball teams. Okay, the first starting 5 players, and we would like to compare their heights together, okay? So suppose this problem is given to you. You've been asked to find the mean, you know, just to motivate the subject. You want to find the mean, median, and the mode. And the mode of the following data set, okay? Of each data set. And this set is going to be that 5 players of 5, okay, 5 starting 5 starting players, okay, on each of 2 men's college basketball team, 2 men's Palmer College or whatever college basketball team. Okay, all teams and their heights in inches, for example. And this is it. There's height in inches. Okay, so we have 2 teams. We may call the first one the first team, team 1. Team 1, we have 5 players, and their heights are going to be 72 inches. Okay, 72, 73, 76, 76, okay, and 76. So this is what would happen for the first team. Okay, and we have another team, our second team. And the information that you have, the heights are going to be 67 inches, 67, 72, 76, 76, and 84. As you can see, they are different. But if you find those measures of centers, they are going to be the same. Okay, so this is going to be the case. So, we are going to find it so that we'll be able to compare that fact. So let's do one of them. Okay, for the first team, and this is going to be the first team. Okay, so for the first team, then the mean, you know that the X bar is going to be, you're going to add those numbers and you divide. So that gives you 72, 73, and you have those 76. So you have 5 numbers, you divide it by 5. And if you use your calculator, you should arrive at 75. So the X bar would be 75 for the first group. Okay, that would be the mean. If you want to find the median, you know that you're going to order it. It's the order set. So it's going to be 72, 73. And that's a 76, 76, and 76. So you are going to have 5 players, 5. So the median is going to be right in the center. It's going to be the position of 2.5, if you like. So that's going to be 1, 2 to the left, 1, 2 to the right. So this number is going to be your median. So the median of this set is going to be 76 inches. Okay, 76 inches, and then we can find the mode. Any suggestion? What's the mode? The repetition, the one 76, yes. The one that's going to be with the most frequency is going to be 76. Okay, the mode, the repetition, it's repeated 3 times. So that would be 76. Okay, so that would be for the first team. And if you do the same one for the second team, you will arrive at the same number. Okay, at the same number. So if you do the team 2, okay, it would be the same. Just write it down. So the X bar again is going to be 75. Okay, if you add these numbers and divide it by 5, the median is clear. It's just going to be 76, and the mode is 76 again. So the median would be, okay, the median of this set is 76, 76, and the mode is also 76. See? So we have 2 different teams with different heights, but their measures of centers are going to be the same. So if you want to compare these 2 together using these ideas, you are not going to get anywhere. And if you look at the height, you see, look at the second one. The second one, you have something like 67 over here and 84. And for the first one, you see the numbers are almost close to each other. So there are something in second team that's going to make it different from the first team. But you cannot find it using these type of ideas only. So this means we need something else. We need something else to be able to compare them, okay, to compare them together. So the conclusion of this argument is that we have 2 different data sets, okay? So in this case, 2 data sets that we consider have the same measures of centers, have the same, okay, we have the same measures of center, but they are different. Okay, but the numbers or the values, the data values, but the numbers are different, are quite different if you like. Okay, so this means We need something else if you want to compare them together. We need something else to be able to continue, compare them together. So the conclusion is going to be, we need something else. We need other measures, if you like. We need other measures to compare this data set. Okay, the measure that we're going to use is going to be called the variation. Measures of variation, or the measure of a spread. So we want to check to see how these numbers are going to be, we compare them together, how the numbers are going to be varied from one to the other one. So what we are going to use is in this section. So we use a new descriptive measure, use a descriptive measure, descriptive measures that indicate the spread, if you like, they indicate the variation, indicate the amount of variation among the data, amount of variation. Okay, that's one expression, or a spread among these numbers in a data set. Okay, so that's a need that we are going to have. There are going to be two different measures. We are going to use them. One of them is going to be called standard deviation. The other one is going to be called variance. Okay, so these are going to be the one. Get to know the name. Sample standard deviation. Standard deviation. This is the name of the one of them. And the other one is sample variance. Sample variance. This is the other name. Standard deviation and the variance are measures of variations. Are going to be measures of variation. In your book, they talk about the range as well, but we are not going to do it. These two are the most commonly known one. Okay, so there is a need to be able to get this one. Okay, so we motivate the subject. Now we are going to make, okay, we are going to get that formula. Measures of variation is going to be, you see, when I give you the result of your test, quickly you ask for the average. So if I give you that the average is 65, then you would like to compare yourself to the average of the class. So if the average is 65 and your score is 80, then you would like to find, the difference between 80 and 65 to find out how far are you going to be from the center. Okay, so this is going to be the case study. This quantity that you have in your mind, how far you are going to be from the center, is going to be your deviation from the center. Okay, the difference between between your number, the difference between your number and the mean. This is going to be what we call it, the variations. Are you done? Again, I want to motivate this formula for you. If the formula is, I can write the formula right away, but it's nice to know because there are different ways to do this one. It depends on discipline that you're going to have in future. So we are going to see what's the sample standard deviation. What is the sample? I focus on the sample. For the population, it's a little bit different, but we don't need it now. We get to this one later. What is the sample standard deviation? Standard deviation. I write the formula for you, but just let's have a little bit of time to focus on this, and then we give you the result. You see the situation that we're going to have if a data set would be given to you. You see, if the data set would be given, let's have a data set. So if x1, x2, okay, x3 up to the xn are going to be given numbers, are given data values. Okay, data values. Then I write the formula and explain it. Then the sample. See, the sample. Standard deviation. Standard. Okay, standard deviation. Deviation of the data set, of the given data set, is going to be denoted by, is denoted, notation, by, be denoted by lowercase s. Anytime you see this small s in a statistic, this means a standard deviation. Okay, it's denoted by the lowercase s, and is going to be defined by, and is defined by, that's the definition. The definition would be s equal to, make sure you write it down correctly. You can bring any formula to the test from now on, and this is one of them. You see, we are going to consider the deviation of each of these numbers from the center. Deviation means a difference. So the first one is going to be x1 minus x bar all squared. This is the deviation of the first grade from the center. And you continue for the other ones. It's going to be x2 minus x bar all squared. And then you continue to get all of them. So the last one is going to be xn minus x bar all squared. Okay, then you divide it by n minus 1. Divided by n minus 1. N is going to be the sample size. So these are the square of the deviation of each number. This is your grade. You compare it to the center. This is the difference. This is somebody else's. Then we square it, and then we divide it by n minus 1. You may wonder why we square it. Because this is the deviation of the first number, the second number, the third number. We should add them together and divide it by n minus 1, or even divide by n. Because this is a deviation of each one of them. You add them together. How many do you have? N. But I divide by n minus 1. Now, there are two technical problems. One of them is if you do a little bit of algebra, if you drop these squares, if you add all these numbers only together, you see x1 plus x2 plus x3 and xn. If you divide it by n, that give you what? That give you the mean. So if you do the algebra, if you don't have the square, all of them would be 0. So in this case, the sum would be 0. Doesn't make sense that the sum of the deviation of the numbers would happen to be equal to the 0. That's why you have to take care of this. So you cannot drop the square. There are two different ways to do it. You can do the squares, as I did over here. And in some discipline, instead of the square, they use absolute value. They say absolute value of x1 minus x bar plus absolute value of x2 minus x bar, etc. So that they avoid it to be equal to the 0. If you use the absolute value, it's not going to be called a standard deviation. And they call it, they call it MAD, M-A-D, if you see this one somewhere. And that would be mean absolute deviation, mean absolute deviations. For the lower classes, when they study high school, statistics, if you like, they use that idea. If you see it somewhere, it's different. That's why we talk about the squares and we divide by n minus 1, okay? Any question? Then you may wonder, why n minus 1? I should divide by n because I have n numbers. There is a difference to do it. We do it for the sample. If you do it for the population, then this would be n. It's the one that we are going to use in future, not now. But when you do it by sample, you divide by n minus 1. If you read your book or some other statistic book, they ask you this question, why n minus 1? But some of them, they answer, oh, because the statisticians are crazy, instead of n minus 1. But it's not really the case. The case is, since you pick a sample, you pick a sample from the population. You see a sample from the population, and that's why you need n minus 1, not n. The reason that you need n minus 1 is that if I ask you this question, if I ask you, give me, for example, 5 numbers whose sum is equal to 20. Just because somebody asked me this question before, so I give this answer, which is mathematically something that we do. What's the answer? If I ask you, give me 5 numbers whose sum is equal to 20. Just pick one. 5 numbers whose sum equal to 20. No, 5 number whose sum is equal to 20.
You could have 4 fours.
Yes, you mean 5 fours.
Or 5 fours, my bad.
Okay, this is one of them. Very good. Any more? Here's 5 numbers whose sum is 20.
1, 2, 3, 4, and 10.
1, 2, 3, 4, and 10. Very good. Very good. You see, when Wesley wants to give us this one, he didn't pause for 1, 2, 3, 4. But you have to pause for the last one. You see, if I ask him, give me 5 numbers whose sum equal to 20, you always can give us the first 4. You know, you pick the first 4. But since you want to make sure that the sum is 20, you stop and then you pick the 10. You see? Yes, 5, 5, 5, you see? Anything you like. You may say 4, 5, 2, 1, then you stop to get the other ones. Because this is going to be 9, 11, 12, then you say 1, 8. You see, if you want to pick 5 numbers, you have the freedom for picking 4 of those. You have the freedom of picking 4, because for the last one, you don't have the freedom. You have to make sure you add them together, you get 20. That is why we get n minus 1 here, you see? Because this is the sample. It's a sample of n numbers. When you want to pick a sample of n number, the first, you see the n minus 1, one of those are free. So that's why we call it degree of freedom. That's why we divide by n minus 1. You know, if you want to get the reason that, because it must be n when you divide it by the total one. It's true for the population. It's n minus 1 because you are going to pick n numbers and you have a freedom for n minus 1 of those. Okay, so that's going to be the one. Now we usually make this one into the brief form. Use sigma notation. So S is equal to the sigma notation for the top would be sigma of, we write x minus x bar, okay, all squared divided by n minus 1. That's it. That's going to be easy to handle if you like, for this formula. So this is sigma, you know that this means you are going to find the first number, x1 minus x bar squared, then plus. The second one is squared plus that give it the numbers. That would be in brief form, okay, for the standard deviation. So this is going to be sample standard deviation. You can use calculator to get it, I show you. Then, but we need it to know it. Okay, so this is going to be, we call it a deviation because the x minus x bar. When we want to calculate it, we usually find the s square first. because s squared, you won't have the radical, it's easier to find. But this s squared is going to be called sample variance, okay? So the sample variance, sample variance is denoted by, is going to be denoted by s squared, okay, s squared. So your s squared, usually find s squared first. S squared is easier to find, so it's going to be sigma r, okay, sigma of x minus x bar all squared divided by n minus, that's sigma x minus x bar, okay, all squared divided by n minus 1, okay? So that would be sample variance. Sample variance. Have to find it for us on the next test. Okay, in this formula, that is going to be, if you like, where this n is sample size. Okay, n would be sample size or number of values. Number of values. And of course, x bar is what is sample mean. Sample mean. Okay, so we give you a data set and we ask you to find it for us to get these numbers done. Okay, any question? Let's go back to one of those two teams that we talk about it and get this number. It's your job. A set of data would be given and they ask you find the standard deviation and the variance. Any question? So let's do it, and then there is easier formula to handle. I give you that formula too. So this is the example. We wanted to find the variance and find, okay, find the variance, and a standard deviation. As I told you, you can bring any formula you like from now on to the test, and it's going to be quite a lot. Okay, find the variance and the standard deviation. The standard deviation of the sample. This is it. The sample is those heights that we talk about. It's 67. Yes, question? What's question?
Oh yeah, could you go back to the other page real fast just so I could see what X? I just didn't see. Okay, sample mean. Okay, thank you.
X bar, remember X bar. Okay, that's X bar. So this is going to be 67, 72, 72, 76, 76, and 84. Okay, that's going to be 84. So you see, if you want to do it without calculator, I'll show you the calculator later on. So remember the formula for those sigma that we did have, you see that's your formula. You have to find this x minus x bar, add them together. For any sigma, we're just creating this column. You see this can be done quickly, even without any calculator. So we have a table here. This is going to be x, the numbers. This is going to be x minus x bar. And this is going to be x minus x bar squared. And you know that you add this square together, that gives you sigma of x minus x bar squared. You divide by n minus 1, and then you're done. Now in this table, the numbers here are 67, 72, 67, 72, 76, 76, and 84. Okay, that's the values that you have. With this formula, you have to find the x bar first. So what you're going to do, you are going to add these numbers together. Okay, if you add them together using your calculator, that gives you 375. So this would be 375. So this 375 is what? Is sigma x, sum of all the numbers, 375. Now we are ready to give you the mean. Mean, remember, x bar is this total, sigma x, divided by n. The sigma is 375, and the number of observation is 5. Divided by 5, so that gives 75. So your x bar is 75. Okay, that's going to be your first step. Any question? You need the mean because you have to fill up this column. Okay, now go and find the difference for each one of them. You see the first one. Are you ready? So we're going back, x minus x bar, 67 minus 75. And you continue, 72 minus 75, etc. So this is it. So that gives you 67 minus 75. Okay, if you subtract it, that gives you negative 8. Over here, you square it, negative 8 squared, which is going to be 64. Any question? And you continue for the other one. Over here, 72. 72 minus 75. So that gives you negative 3. You square it, that gives you 9. Negative 3 squared. Next one, 76 minus 75. That gives you 1. You square it, that gives 1. And this is the same, 76 minus 75. 1, that gives us 1. This last one is going to be 84 minus 75. That gives you 9. 9 squared would be 81. That's it. Any question? You add these together. If you add them together, that gives you 156. So what is this? This is sigma of x minus x bar all squared. 156. Now we are ready to get the standard deviation. Okay, what is the standard deviation? We go with the variance first. Remember s squared. I repeat the formula so that you now remember it. S squared is sigma of x minus x bar all squared divided by n. So that would be 156 divided by n, which is 5. Okay. And then, so 156 divided by, sorry, this is n minus 1, remember? This n minus 1 is going to be 5 minus 1. So it's going to be 156 divided by 4, which is going to be 39. So s squared is 39. That's the variance. Okay, that's going to be your variance. And you take the square root. So s is going to be radical 39, and radical 39 would be 6.2. So s equal to the 6.2 is going to be what? This is going to be sample standard deviation. Sample standard deviation. And you're done. And most of the calculator will give you these numbers right away. And you can use calculator if you don't mind. You can use calculator if you like on the test. Okay. So for example, any question?
Can you move the paper up a little bit?
This one?
Yeah, thank you.
Okay. So most of the calculator would give you this information right away. It's nice to know the method because there is going to be one case that you have to do the method. And sometimes it's going to be easier to just do it. But to know it, you have to do this data in your calculator. TI 83, 84, but it's much cheaper one. For the standard deviation, of course, those ordinary one would give you the result right away. So if you're using this, this is TI 36. So you have to put this data in first. Okay, that's one. So the data that I have is the numbers are 67. So that's going to be 67. Then I have a 72. So that's going to be 72. Then I have 76, 76. Okay, another 76. That's a 76.
How'd you
Then I
pull up
have,
that table?
which one?
The table on the graph?
This
Or
one.
on the calculator? Yeah.
You just put on the data.
Oh, data.
Yeah,
Alright.
data. So let me just these. I should just get the 84 as well. 84. So I have all my information. Okay, I just put this data in. So then I have to the statistic to find this operation that I need. Okay, in my calculator, statistics is with the data you see here. This is the data statistics. I have to go to the second. So I click on the statistic. That gives me a number of the operation that I can use. So what I do, I'm going to do this one variable statistics. So I have to go to the 2 or bring it down. So I go to the 2. You see, then I want to calculate. So I go down. So down, this is calculate. So when it's calculated, it calculates a number of things for you. You see, it calculates the X bar for you, which is 75. X bar is 75. The next one, S, standard deviation. The standard deviation is 6.2. Okay, and that give you more. You see this next one, sigma X, is the one we call it population standard deviation later on. We divide by n minus 1, you get 6.2 for the sample. In future, we divide by 5, that gives us 5.5, but we don't need this one. Okay, more. This is sigma X, 375 that we got it over here. So this is 375 that we have. And if you go down, that give you sigma X square. I'm going to give another formula in a minute. So it would be useful, the minimum, the maximum, etc. And that's the mean. Remember the median. The median is 76. We already talked about it. And these quarter 1, quarter 2, these are going to be the one that we're going to use later on. So it's not bad, okay, and not difficult to operate. If you have even ordinary calculator will do it for you. Not bad to try, but you have the option. I don't mind. And this one can be done quickly. We are not going to give you any complicated one. So it can be done in either ways and be accepted if you can do it. There are a couple of things that at the end of the course that I give you all handouts for all of them. So you don't need any advanced calculators to do it, and I don't follow it. But if you do it on the test, we don't mind. But you have to tell us that you did use this calculator to get these numbers, okay? For the TI-84, you have to go with something else. You see that's a TI-84. In the TI-84, you have to go for the list. I think that's you see that's a statistic in the TI. Let's see if I'm right. I haven't worked with this one for a while, but you see that's the statistics that we have. If you go to the second, and that should give you the data somewhere. That's going to be the L1, and it's appear somewhere or somewhere else that we can get that one. Maybe here. Okay, if you go to the statistics, which is a number 5, and that give you those numbers. I'll check it and tell you. There is around these statistics that I'll come back to it and I show you what is going to be it's not calling data, and you must go with that. You see, that's going to be the statistic one, and that is the one. Then I'll show you this one. There was a place that, yeah, I show you, but this is going to be around these statistics and the variables that we get it somewhere in this this format. Okay, I'll come back and show you. Anyway, I usually work with this one. It's do whatever you do with the TI. It's much easier and it's cheaper. But I'll show you that one too. I check it. But as we go on, I just, there are a couple of places that would be nice to know that the calculator, and it's, it's part of the deal that if you get these numbers. Okay. The data that I use, you see that was the one. This is the one that I use is a brief one and it's easier to handle. You see in this one, you click on the data. You see, I clear this one. You see, that was, let me turn it off again. Turn it on. You see, that's the ordinary one. Even those calculator, very small one that you have, scientific one, will do it for you. You see, that's the data. So that give you this column, L1, L2, L3. If you want to clear this one, you can clear it. You see, that's going to be the one. I clear it, and then I just put the numbers here. This is much easier. Then I click on the statistics that give you various operations that we can do. Okay, I did the operation with this one. Okay, with the number two. Number two automatically in this case will give you this one. There are some other this random variable, etc. that we can do. Okay, let's finish this one. Then I come back to it and I show you all of them from time to time that we go on. And some of them are very nice, really, to know it. Because today this is science, technology. Even I have the calculator I use for a statistic is just a small scientific one. It's a little bit confused with or the other one, but I can show you that one too. Okay, this is not the formula that the calculator used for you. I'll show you in a minute. Okay, let's get back to this one. So, the data would be very, limited one, so we can find it. We get a 6.2. Now, the way the calculator will do it for you, the calculator won't use this formula. Okay, this is the one that we are going to use. The one that with is sigma x minus x bar over n minus 1. You see, if you do a Riemann algebra, x minus x bar, you square it, expand it. If you expand it, that gives you much easier formula to operate. Okay, so this is going to be the case. So just give you a remark regarding the formula. Okay, so the calculator would try to limit the number of the operation that we have. This formula, we call it computing one, because this is the one that we use to compute. It's much easier than the one that I used. Okay, computing formula, we call it. Computing formula for a standard deviation. Standard deviation. What is this formula? So as I told you, if you use a Riemann algebra distribute those squares, your formula would be much easier to add. This is the one. S squared equal to variance. You see, the top would be changed into this format. Would be sigma of x squared. Okay, minus. You get a quotient. On the top, it's going to be sigma of x all squared. Okay, divided by n. And then divide by n minus 1. It's the same formula. You see, when you expand it, there is no x bar. It's like we substitute for the x bar. Make sure you write it down correctly because we are going to use it in several places. You see this one? Sigma x all squared, then divided by n. The one in your book, they find the common denominator, they bring this n down, they give you n times n minus 1. You can use that one too, but I prefer this one. So this would be the formula for the variance. Okay, this is going to be the variance. And of course, if you take the square root, if you take the square root, that would give us a standard deviation, which is going to be sigma x squared. Okay, sigma x squared minus sigma x all squared. Okay, divided by n, and then everything divided by what? N minus 1. So your calculator will use this formula. That's why you saw sigma x and sigma x squared. So that would be sample. But you can use either one. Sample standard deviation. Okay, that's going to be the deviation. Okay, so if you want to use it without calculator, I suggest that this is a new one. So let's try the same problem to see what's going to be the difference and which one is going to be easier or which one you prefer. Any question? So let's do the problem again, but using this version. So what was the problem you would like to find? Okay, find the variance. Find the variance and okay, variance and standard deviation. Variance and standard deviation. Standard deviation of the of the sample. Sample is the same one. The number, remember, was 67. 67 inches, 72, 76, 76, and of course 84. Same one. You see, if you want to use this formula, look at the sigma. You need sigma x squared and sigma x. So you need only two columns. One column for the x, one column for the x squared. That's why they use this formula, which is much easier. So you need only two columns. One column you're covering x, and the other column you're calling x squared. You add these together, that gives sigma x. You add these together, that gives sigma x squared. And you substitute here, and you get your variance and take the square root, then you'll be done. Okay, so bring the numbers again. We have a 67, 67, then you square it, 67 squared, just to give you the numbers, Again, calculator will do it for us. 4,489. And then we continue. You see 72 squared would be 5,184. And then we continue. 76 squared. 76 squared would be 5,776. We have another 76. 5,776. And then we have 84. And if you square it, that gives 7,056. Okay. So you have to add these columns together. You add this one, we already did it, 375. And you add this one, and that should give you 28,281. Okay, so this is sigma x. So the sigma x 375. And this is sigma x squared, which is 28,281. And you know that the n is the number of the observation is 5. Okay, now you can quickly use that computing formula to get your result. So your s squared was, I just repeat the formula, is a sigma of x squared minus sigma of x all squared divided by n over n minus 1. You simply substitute. Sigma x squared is this one, 28,281 minus sigma x then a square. Sigma x is 375 all squared divided by n is equal to 5, and the 5 minus 1. Order of the operation, you square the top pairs and you divide it by 5. So you should get 28,281 minus, then you get 28,125 divided by 4. If you subtracted the top, that gives you 156 as before, divided by 4. So that gives us the same number, 39. So s squared would be 39, as we did it with the other formula. Okay, so that would be your variance. And you take the square root of 39 would be 6.2. So that gives you the same, okay? That gives you the same answer, if you like. So from calculator point of view, as I told you, this this new one, this new formula is much easier. It's easier to handle, and they usually use use this one to get the numbers. Okay, any question? So decide what you want to do. As I told you, on the test is not going to be quite a lot of numbers. It can be done, quickly, but it's nice to know how you can use calculator at the same time. Most of your problems are going to be this S would be given to you. Okay, a standard deviation would be given to you, then you are going to do something else to it for us. Okay, so it's not the case that you always have to use calculator to get these numbers. Okay, any question? Now, there is another one, unfortunately, in your book. This next one, it is the book, but it's not during the lectures or the sections, because as you know, we are going to have two types of presentation of the data values. One of them is like this one, a bunch of numbers would be given. That's it. But you know that if you have something like 1,000 numbers, they are not going to list all the 1,000 for you. What they do is they form, as you know, frequency distribution table. So the information would be given to you as a frequency distribution table. This means you are going to have, remember, you are going to have classes and the frequencies only. So you don't have the 1,000 number, but you do have the classes. So what we are going to do is, in order to find the mean, a standard deviation, and the variance of those type of questions, we have to modify these formulas to be able to get it. Okay. So as I told you, this is a part of one of the problem in your book, but we very much want it, and then we are going to show you. Okay, yes, the two formulas, both of them give you, both of them give you the same answer. And we call this one computing, because this is the one that, your calculator would do it. That's easier. You know that when you want to use a device like computer or the calculator, you are interested in minimum number of the operation that you can use. So this is from the calculator point of view, is going to be the one that calculator would do it quickly for you, rather than the one that I did, X and X bar. Okay, so that's why we call it computing formula. Means we are going to use this one to compute. But both of them give you the same result. Do whatever you like. Okay, I use only this one because I want to extend it in a minute, and you will see that the extension is going to be the one. Okay, so pay attention to this next one. It's part of the problems, but you are going to be given one question. So when we want to find the standard deviation and the variance, there are going to be two cases. Case one, a bunch of numbers would be given, all the individual numbers would be given. Use the formula that I talk about it. But the second one, most of the time, a table would be given to you. Classes, remember, frequency distribution is going to be classes and the frequencies. And they ask for these three quantities. So make a note, this is not directly in your book. I mean, it is in the part of the problem set. So what is this? Finding the mean, finding the mean, variance, mean, variance, and standard deviation. Standard deviation. If you want to do this one with calculator, it takes time, but you will do it manually. Okay, find the mean, variance, standard deviation of what? From a given, okay, from a given frequency distribution. So a table would be given to you and you want to find it. Frequency distribution. Okay, so you don't have the actual numbers, but you do have classes and the frequencies. Now what we are going to do, we have to modify those three formulas that we did have. Okay, are you ready? The first one, how are we going to find the mean? You see, let's see what is your formula for the bunch of numbers and how we're going to generalize it to this frequency distribution table. So we recall, I do the first one, then I list all of them. Recall that. What is the sample mean formula? The sample mean formula is what? X bar equal to sigma x divided by n. This is where all the numbers are given to you. But remember, when you have distribution table, you don't have the numbers. You have only classes, okay? You have only the classes would be given to you. You don't have the actual, just want to bring one of them so that you compare them together. You see, remember, this is the one that we did for our practice test. You see, for this type of problems, this would be given to you. Classes and only the frequencies. Classes and the frequencies. Now, in order to get the mean, you see, you are going to add all the numbers together, divided by the total number of the observations. Now, for example, for this one, how many numbers do you have? You see, the total frequency is 30. You have 30 numbers, but you don't have it. You have the actual numbers. The way we are going to do it, you see, we go to this first class. You see, remember the midpoint? The midpoint is 5.5. And there are 10 numbers in this class. We imagine that all the numbers are the same and all of them are the midpoints. So how many 10 numbers in this class means 5.5 plus 5.5 plus 5.5 plus 5.5. So if you want to add all the members in this first class, it's going to be 10 times 5.5. So that would be sigma x for this class. Any question? You see, there are 10 numbers in this class. If you want to find the mean, you have to add all the 10 together. Remember, you have to add all the 10 together, but you don't have them. What you're going to do, you pick a representative of the members. Representative is the midpoint. So it's going to be 10 times the midpoint. 10 times, 5.5 if you like. So that gives you 55. We go to the next one and we do the same thing. We do the same thing. So if you do the same thing, you see this the top one would be changed into, okay. So in this case, we are going to replace those x's by the midpoint, okay. So we replace the x's by the midpoint. So this is going to be the result now. If xm midpoint. XM is going to be the midpoint. The midpoint of each class. Okay, and F is the frequency of the class. Is the frequency of that class or of the class. If this is going to be the case, then see your formula now is going to be this one. X bar equal to is going to be sigma of not X. Remember, replace the X by XM. How many XM do you have? You multiply by the frequency of the class. It's going to be sigma of F times XM. Okay, F times XM divided by N again. Okay, you can divide it by N. This is going to be, N is going to be the same as the total number of the frequency. It's going to be sigma of the frequencies. Okay, this is going to be XM. Then you note that the total number of the frequencies is also equal to the sigma F is equal to the N. Okay, so this is going to be the total frequencies or number of data values. So, you can write down in this format too. X bar is going to be sigma of F times XM divided by N. So that give you the mean. Any question? You go to each class instead of X. You see, instead of X, you pick XM. So you assume that all of them are the same. XM, 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 XM. How many XM? Depend on the frequency of the class. And you add them together, they give X bar. Okay, any question? So that's formula for the mean. Formula for the mean. Now we can do the same thing for the variance and the variance and standard deviation. Variance first. Variance. Okay, let's see, variance. Now, what are we going to do for the variance? The same thing. Recall that I use the computing formula. You see, I need that one. So we recall that ordinary one is what is S squared equal to the sigma X squared minus sigma X all squared divided by N minus 1. Now you replace the XS by XM. Okay, so this is going to be the case. And we say that so the variance of a frequency distribution table is what? Change. This is going to be a formula. S squared equal to sigma of, you change the X into the XM. So all of them are going to be the same. XM, XM, XM. How many? F times XM squared minus sigma of F times XM all squared divided by N and divided by N minus 1. So we replace the X's by midpoint XM, but since they are going to be all the same, so you have to multiply it by the number of the observation. Number of the observation in each class is going to be frequency of the class. Okay, so this is going to be the variance. You take the square root, that gives you the standard deviation. And S is going to be, is the standard deviation. Okay, standard deviation. Again, where I just remind you, the midpoint. The midpoint was what? Remember? The average of the lower class limit, lower class limit plus upper class limits, upper class limit divided by 2. This is the one that, you know, you better do it directly rather than the calculator one. It can be done also by calculator, but you have to, okay, you have to enter, if you like, all this information to the calculator to get it. It can be done, and there is I can show you that one too. Okay, I'll give you a break. We come back and we do it. We need a table. You have something like 4 or 5 in your assignment, and we give you one of them. You better practice to be quick, to be able to do it. Okay, then we have all the, you know, we considered all the possibilities, and then we can like look into some of this application. Okay, it's 11:24, 10 minutes, 11:35, 34. Come back and we try this one. See you then. Okay, so let's take one example to see how we're going to apply this formula. Okay, to get all those four problems. So, example, a frequency distribution table would be given, and they ask you to find this quantity. So I would like you to find, okay, find the mean, and find the mean variance, and a standard deviation. And standard deviation of the following, okay, of the following frequency distribution table. Following frequency distribution. Okay, so there you are. This is all you are going to be given. So we are going to have class or classes and the frequency. In this case, this is it, class between 0 and 24, frequency of 560. Okay, so 560. Then a class between 25 and 49, 320. Okay, then the class 50 and 74, frequency of 80, and 75 and 99, frequency of 40. So this is all we'll be given. You see, as you can see, there are 516 numbers between 0 and 24. So you are not going to give in all the numbers. So this is the way we're going to do it. So what you are going to do, you have to extend this table and remember those sigmas that we have, you need to have the midpoint first. So this is how we're going to organize it. You are going to be needed this table. Okay. So in the first part, it's going to be class. Frequency of the class, which is going to be F, is already given to you. You have to find the XM midpoint. And instead of those X's in the formula, you're going to use the XM, it's a midpoint. We multiply these two together because we need sigma F times X. So it's going to be F times XM. Okay. So when we added that, gives sigma Fx. And then you have to multiply this one by another X to make it Fx squared. Fx squared of M. That's it. Okay, you add these together, sigma F will be N. This is going to be sigma F times X. That give you the mean. And this is going to be sigma F times X squared. That give you the standard deviation and the variance, and then be done. Okay, so you just fill up this table. The numbers that we have, you see the first class is going to be 0. Repeat the classes again here. 0 and 24 for the first class. We have 25 and the 49, second class. Then you have a 50 and 74. And finally 75 and 99. Okay, the frequency, this is the frequency of 560. It's the frequency of 320, 80, and 40. Now you have to find the midpoints. You know that for the midpoints, we added the lower class and upper class, we divide by 2. I show you for this one. It's going to be 0 plus 24 divided by 2. That gives you 12. That is going to be your first midpoint. Now you can do the same with the other, or look at the table. What's a W for this table? The bed? Any suggestion? 0, 25, 50, 75. W is
25.
25. Yes, 25. Very good. That will help you if you like. You know that this is going to be 12. You add it to 25. That give you the second one. 25, 25. You get all the midpoints. Or just calculate it. All of them would be the same. Okay, but the suggestion is the W is 25. So this must be 12 plus 25. Okay, which is going to be 37. If you don't like it, 25 plus 49. Okay, that would be 74. You divide 74 by 2, that gives you 37. So not a big deal. So if you want to continue 37 and 25, you add them together, that gives you 62. And again, you add it to the 25, 67, 87 is going to be the next midpoint. Okay, so it's going to be the average of the lower and the upper, or as soon as you find the first one, you add the W quickly, you get the, you get the other two. Okay, any question? Now multiply. You multiply these two together, that would be F times X. Okay, I just show you a couple of them that write the result. So it's going to be 560. Okay, 560 times that by 12, which is going to be 6,720. And you do the same thing to this one, it's going to be 320. Again, calculator, you don't have to rewrite this. Okay, so that gives you 118 and 40. And if you do the same thing, 80 times 62, that gives you 4,960. And if you do 40 times 87, so that gives you 3,480. Okay, quickly you add this one divided by the total of the first one, and that gives you the mean. And let's finish it. Now we continue. You need fx squared. This is fx. So again, you multiply by the previous column. X times fx would be fx squared. So for example, the first one is, this is 6,720. You multiply by another x, which is 12. If you multiply by 12, that gives you 80,000. 80,640. You do the same thing here. So your x is 320, for example. So I just write it down so that you know it. It's going to be times 320. So it's going to be 438,080. That's one. And you continue doing the others. Okay, that's
I have a question.
yes.
On like the first one, oh, okay, so on the first one in that last column that you did, why'd you do it times 12?
X, you see, you need fx squared. You already got fx, you need another x.
Okay, but then on the second one, you did 320. Wouldn't it be 37 if we're doing it times XM?
You see the x, this one?
Yeah, so in the last column, you did 320 times.
Oh, I know what you mean. That is, must be multiplied by, yes, that's 37.
Okay, thank you.
Thanks. Okay, just check this, if it's going to be the same number. In that case, maybe I missed something. Because if you multiply by 37, then you have to do the numbers again. Let's see, that's, maybe I missed something. So that's going to be 1,840 times that by 37. 37, 43. No, the number is correct. Yeah, but that's 37. But the final answer is correct. Okay, so we continue. I just checked this one too. 4,960. So that will be another 62. Okay, so that gave you 307 and 520. Okay, and the last one, If you multiply it, again, I write it down. You don't have to write these, even you can do it with your calculator, all of them together. But this is going to be the final answer. Okay, so we have everything we need. Now we are going to form those sigmas together. You don't understand by what this one is? Because there was a mistake here. We checked it. You see, that's one. You have to multiply each of these by the previous x that you have. You see, this is so far. This is fx squared. So x is 12. You multiply 12. Again, you have to multiply this one by the x, 37. By the x. So that make it to the, okay. Make it into the fx squared to get these numbers. Okay, so what you need to do is you need this sum here, sigma f, they give you n. If you add them together, that give 1000. So that give you n. N is sigma f, which is 1000. You need this one. You need this sum here. So that give you 27,000. So that would be sigma f times x, which is 27,000. And you need this last one that give you, I think, the 11,290,000 and the 3 zeros. So that would be sigma of fx squared or xm squared. Now bring those three formulas that we talk about it, then you'll be able to find all of them. Okay, already this is it. Remember the xm for this group was a sigma of f times x, or xm divided by n. So that give you 27,000 divided by 1,000, which is 27. So the mean would be 27. Okay, that's the first part. Then we go for the s squared variance. The formula for the x squared, I just remind you that computing formula, sigma of fx squared, xm squared, minus sigma of f times x m all squared divided by n, then n minus 1. Again, of course, you bring all the formulas that you need. So it's going to be equal to sigma of fx squared is this one, 11,290,000 minus, on the top, sigma fx, which is 27,000, 27,000 squared, divided by n, which is 1,000, divided by n minus 1, which is 1,000 minus 1. See, that's going to be the case. Order of the operation, you square divide all of them. So it's going to be 11,290,000. If you do this one with your calculator, that gives 729,000 divided by 999. So this is the way I did it. On the top scale, 400,000. And at the bottom, 999. And eventually it's going to be 400.4. So that give you, okay, that give you the variance, 400 almost. Okay, that's going to be a variance. Take the square root, that give you the standard deviation. So S is going to be a square root of 400.4. 400.4, that give you 20. Almost 20, 20.1. So S would be 20.1. The standard deviation. Standard, okay, deviation. Okay, it's nice to know. We are not going to use it, but we use the first part. That bunch of numbers that I talk about it is going to be used right through the end of the course. That's a standard deviation. We need that one. And even when you get to the final, there are 3 chapters that we do different things, but always there is one problem that you have to find the standard deviation. So, if you can sort of your calculator to do it, so that would be good for you, to get that one. But this is also nice because this is what will happen actually, because you have a bunch of, huge, your data is going to be huge. So you are not going to add all the numbers together, even if you want to use with calculator. Okay, so that would be the computing part of this type of argument that we did. We're going to find the mean, standard deviation, the variance, and these are going to be the quantity that we're going to use it for all, all data set that we're going to have. Okay, any question? So make sure that you sort it out, how you want to operate with these 2 questions so far. The one that 5, 6 numbers would be given, they ask for the mean, standard deviation, and the variance. And the other one is the bunch of, that's it. Frequency distribution table would be given, then you sort it out for us. Now we get to the kind of application, why we've been talking about this type of ideas. The quick one is our original question. The original question was, if we're given 2 different data sets, we want to compare them together. Now we have the standard deviation, which is much better quantity. But the difficulty is going to be when you want to compare 2 data sets together, they should have this, if they have the same units, measurements, it would be easy to find the standard deviation, compare them together. If you talk about the dollars in both cases. But sometimes one of the data set, for example, maybe dollars, your salary. The other one may be number of the hours. So one data would give you hours, the other one would give you dollars. So of course, you cannot just find the standard deviation or the mean and compare them together because you have 2 different measurements. So what we're going to do, we are going to introduce a quantity that's going to be independent of any measurements involving the standard deviation, and we compare them together. This quantity that enable us to measure comparison of 2 data set is going to be called coefficient of the variation. It's like a percent that we're going to do. Okay, so it's going to be easy question, but very popular. And that would be the 3rd problem. I told you 4. The 3rd problem that usually give you on the next test. So what is this idea? The idea is comparing. Okay, comparing variation. That's what we were interested in. Comparing variation in different, in different samples or population. We go with the samples or populations. Okay, we want to compare them together, to investigate what's going on. So what we're going to do in order, do this comparison in order to compare. Okay, compare variation for values. For values taken from 2 different, taken from different sample. Different samples. What we do, we apply we apply this quantity. The name is the coefficient, you must know the name. Okay, that's it. Coefficient is going to be coefficient of the variation. Coefficient of variation. That's the expression. Coefficient of variation. It's going to be a kind of percentage denoted by CV. So it is denoted, the notation, denoted by CV. It's not like your resume, but we call it CV. Okay, it's denoted by CV, and what is this? It's a ratio. It's the ratio of the standard deviation by the mean. So denoted by CV, and it is the standard deviation, the standard deviation relative to the mean, relative, okay, to the mean. So this is the formula. You can bring any formula. I've given this one on the test. Some people, they just miss the formula. You see, make sure to write it correctly and bring it to the test. You see, it's a standard deviation, S on the top, relative to the mean, divided by X bar. I've seen some people, you know, they flip this one when they want to give the result. They write X bar over S. This number must be less than 1. It's a decimal number. If you use X bar over S, you are not going to get that one, and doesn't make sense. This is going to be a decimal number. So you have to express it in percent. So you multiply by 100 and add the percent sign, or move the decimal points twice to the right. So in your book, they write it down here times 100%, but I'll just show you, but I'm telling you that it must be given, okay, CV is going to be expressed, and you must do it, expressed, okay, as a percent, as a percent. So if you like the version of your book, this is the version that you see in your book. CV is S over X bar, okay? They multiply by 100, and then they add the percent sign. It's the same thing, you know. It's going to be decimal number. Move the decimal twice to the right, it's percent. So this is how you see it on your, you know, in your book. Okay, very easy formula and very nice quantity. It's nice, but we are going to have a better one later on. But for the time being, you know, the problem is going to be straightforward. The situation, I'm going to give you one, and you know, we shouldn't miss this one really to get numbers. Any question? So coefficient of the variation, a standard deviation relative to the mean, X bar than the denominator. So the way you are going to use it is going to be the following format. Sometimes they give you the problem, and then they may ask you to make a comment at the end. You see, look at this one. A kind of standard example is going to be, suppose you're taking 2 different courses, calculus and statistic, and you want to compare your, you know, we would like to compare the variation of the grades, you know, in calculus course or in a statistic course. You know that the calculus is more difficult than a statistic. So you may not see very much variation in the grades of the students in statistics class, but you may see this one in calculus. So they give you something like it's very popular, you know, just give it a hint, the type of problem that we have, okay? There's no other type. So that's it, the average. You read it carefully, collect the information carefully here. The average score. The average score of the students. Average score of students in a calculus. Okay, in a calculus class, the mean is 110. Okay, with the standard deviation of 5. with standard deviation. Standard deviation 5. Okay, so this is for the calculus class. Their mean X bar is 110 and their standard deviation is 5. But we have another class, a statistic class. And in this class, the average. Okay, average score. Average score of the students. A score of the students in a statistic class, stat. In a statistics, the average is 106. Average is 106 with the standard deviation. Okay, with the standard deviation. Standard deviation 4. Okay, we want to check which grades or which class is more variable. I mean, the distribution of the grade of the students. Okay, so we would like to find which class is going to be more variable. More variable, of course, in terms of the scores. In terms of scores. Okay. So they usually give you the hint, they say use coefficient of the variation, but we don't have anything else so far. So we don't need that hint, okay? But you know, it may be given to you. So what we are going to do, we just using the solution. Okay, so you have to find the coefficient of variation of each one of them and then compare them together. Okay, so suppose we start with the calculus class. Okay, this is going to be calculus. In the calculus class, the mean is 110. Okay, that's the mean of the class. Okay, and the standard deviation of 5. So standard deviation S is equal to the 5. That is the calculus class. So we can find the coefficient of variation of this class first. Okay, so the coefficient of the variation, the CB, is going to be a standard deviation over the mean. So in this case, you are going to have the 5 on the top and over 110. Okay, you simplify using your calculator, which is going to be 0.0454. Since you want to change it to the percent, so 4 decimal places would be fine. But you have to change it to the percent, remember. You move the decimal points twice to the right. Okay, so this would be 4.54%. Okay, so this is going to be the variation of the calculus class. 4.54%. Okay, that would be calculus. Okay, any question? Now we do a statistic. Same thing in the statistic class, the mean is 106. The standard deviation is going to be 4, so it's going to be 4 over 106, and then you compare them together. Okay, are done. So do the same thing for the statistic class. Okay, there you are. We go to the statistic class. Statistics. Information that you have is the mean is X bar is 106. The standard deviation for this class is 4. So your coefficient of the variation is going to be a standard deviation relative to the mean. So that would be 4 over 106. Okay, you simplify it on using calculator. That gives it 3.8%. So the coefficient of the variation in the statistic class is lower. See, the other one was almost 4.5% for the calculus, but this one 3.8%. I know, and that's natural. You have to make a comment. Okay, the comment is going to be, we're going to make a comment that the calculus class or calculus. Okay, calculus scores. Calculus scores are going to be more variable. It's going to be more variable than the statistic one. Okay, and it's clear that the points are going to be different to get these numbers. Okay, any
Professor,
question?
I have a question about this.
Yes.
So when it says, when you made the statement here that the calculus scores are more variable, to be clear, that means that the scores in the calculus class vary from the mean value more than the scores in the statistics class vary from the mean value. Is that an accurate interpretation?
Yeah, because the variation, the definition is relative to the mean.
To the mean.
So,
Okay.
yeah, so that's
Thank you.
that's included. Yeah. And there is another one that would be much better. We talk about it later, but we call it the z-score. But this one, this is all all we can go and get this one. Okay, so this is the third problem. There is another problem. This is also a classic result. We are going to use one version of this problem that gives us a better understanding of what's going on really. You see, what we did so far, we just identified the center, which is the x bar, the mean, and the standard deviation just tell you that how far you are going to be from the mean, okay? So if you want to, how far going to be from the mean, you can find the difference if you like, and just talk about it. Or you can use that, you can express everything in terms of the standard deviations. You see, the idea of this next argument that I'm going to talk about it is going to be this one. You see, look at the numbers that we have. So this is going to be a kind of setup data set that you have. So the center is going to be the x bar. This is the center. And the question was, you got your grade, you want to know what is going to be your relationship to the center, if you like, to see how far are you going to be to the right or to the left. So what we are going to do is, with the standard deviation, we make something a standard, if you like. We get some measurements, if you like. So what we can do, we can divide these portions in terms of the standard deviation and then find out what is going to be your situation you're going to have. So if you want to change it in terms of the standard deviation, this is the x bar. We go to the right, okay, as far as one standard deviation. So this point is going to be, x bar plus one standard deviation. Okay, so this portion is s. I do one more, so that give you s bar plus 2s. Then I can go on forever, but we don't need to go match. You see? So we just create a measurement so that we able to compare the grade of everybody, if you like. So it's a kind of a mirror image. So it's going to be having the same thing here. So this is going to be one standard deviation, which is going to be x bar minus s. And this is going to be another one, x bar minus 2s. And this is going to be another one, which is going to be x bar minus 3s. Okay. So if if your number is going to be somewhere here, you see, if your number is going to be here, and you will find out that you are 3 standard deviation above the mean, because this is a positive. But if you are going to be here, for example, so you are going to be what? 2 standard deviation below the mean, if you like. So you can create different intervals because it's going to be all numbers. These are going to be all numbers. So you have different intervals that will tell you where are you. So that somehow that should give you the position of your grade in the class. Now, we are going to see various measurements when we get to the next section. But in this section, there is a result. It's a classic result. It can be proved. There are some results that they are not classic. We call it empirical. Means based on experience, you can guess. But this is a very classical one. This classical one will tell you that. You see, we don't have anything for this portion, 1 standard deviation, but we do have some for this one. Look at this one. So in this interval, remember the number would be given to you. So you do have the X bar, you do have the S, you substitute, you find this interval. So this result was proved by a Russian mathematician. His name is Chebyshov. He proved that, you see, he proved that 75%, you see, he proved that 75% for any data set, 75% of the numbers must be in the range of 2 standard deviation from the center. So this means if I give you a fair test, okay, and if I got the result, I know what's going to happen to the result. I find the mean and the standard deviation. So 75% of the class grades must be in this range, unless, I did a mess or, I give you a very unusual exam, if you like. So that gives you 75%. So we can guess this one right at the beginning because we know the base here. And this is one observation. His second observation is that almost all the grades must be here. You see, almost all the grade of the class must be within 3 standard deviation from the center. And he actually proved that the percentage going to be, okay, 89%. 89%. So he proved that 89% of the grades of the data values must be within the 3 standard deviation from the center. Okay, so if it's going to be just a good one. So these are some cut point, if you like, some percentage that you have to know it when you're dealing with this problem, this last problem, which is a Chebyshov theorem. Okay, and you may question, oh, so how we find out 75% and 89%? Maybe you are interested in 55%. You are interested in 64%. So how are we going to find it? He just give you the result. The result is, if you just pick any, you see this is 1 standard deviation, 2 standard deviation, etc. He proved that if you pick any number you like, you see I pick something here, okay? I pick something here and something here. I don't know how much in standard deviation is going to be. I know that between the 2 and the 3. So what I'm going to do, I'm going to call this one K standard deviation from the center. I call it X bar plus K. Then I will find the K for you. And this is going to be X bar minus KS. So if you want to know what percentage of your data set is going to be K standard deviation from the center, he got the theorem for you. You see, quite interesting. He proved that. That's it. He proved that at least 1 minus 1 over K squared percent of your data must be within K standard deviation from the center. Quite interesting result. If you put k equal to 2, that gives 1 minus a quarter, okay? 1 minus a quarter would be 3/4, which is 75%. If you put the k equal to 3, that gives 1 minus 1, 9. 1 minus 1, 9 would be 8, 9. And if you simplify that, give 89%. So these 75% and 89% are special cases of the big one. But 75 and 89 is, is popular cases that we're going to have. Okay, yeah, so this is going to be called Chebyshov theorem. So the Chebyshov theorem, let's see, I don't have time to talk about it. I write it down for you next time, and there are 2 problems I have to explain it. It's quite interesting because the percentage would be given to you, they ask for the range. You must know that 75% refer to the true standard deviation. So easily you find x bar minus 2s and x bar plus 2s, and you're done. The other problem, which is more involved, the range would be given, they ask for the percentile. This means you have to find the k. Okay, there are 2 problems. I talk about it next time, and we finish this, this section.